Alright, next question number 13, my fifth video of vectors revision. Write this. In the usual notation, let 2 vector I plus 3 vector j, 2 vector I plus 3 vector j and 5 vector I plus vector j be the position vectors of 2 points P and Q, respectively with respect to origin O, Also, let R, capital letter R, is a point on the straight line. Also, R is a point on a straight line through P such that vector PR multiple vector OQ equal to 0 or 0 vector. Show that OR equal 2 plus 5 lambda into vector I plus 3 plus lambda into vector j. Show that OR equal 2 plus 5 lambda into vector I plus 3 plus lambda into vector j, where lambda is a real number. Full stop. Find the value of lambda such that OR perpendicular to OQ. This is an important question. My note, if you watch my all from 1 to this 5th video, 13th question under vectors revision type. Okay, now here usual I means along the x-axis unit vector, j is the y, along the y-axis unit vector. So respect to O, they said PQ 2 points and their vector form is given. So we mark and draw that. So show the diagram. Take O here. P is given 2I plus 3j. As a Q here, a point Q. Q is 5I plus j. Okay, PQ. And there's a new point R. Where is R? R is a point on the straight line through P. So it can be somewhere here or here. Any point through P, straight line. On that R available. R is lie on that line through P, right? Also they said PR multiple R here. First time I am showing this question. This is the scale, not a scalar product, vector product. So stop it. I'll show something about the vector product. Vector A, vector B, angle is theta. Define the vector product. What is vector product? A multiple B equal mod of A, mod of B, and what? Sin theta. And also there's an n, vector n. In the syllabus we have that vector product, but no, so far no question of past papers. Some small ideas or application only they say teach in the classroom, the school teaching process. This is the vector product definition or the equation. Dot product is, or scalar product is what? A dot B is mod A, mod B is cos theta only. Here sin theta. And what is n? N is like this. Where n is what we call unit vector in the right hand system. If you turn this A to B, if you turn this vector A to B direction, where is the screw? Like you know the Fleming's rule of like that. Yeah, where the screw comes, if it's come up, we call that side, that direction, that perpendicular direction, that n is a vector, but unit vector, right? If n is come down, we can put minus n. But the modulus is 1, okay? It's the basic idea of the scalar product. So here, if this is become 0, what happen? A multiple equal to 0. If you see the dot product, A dot B 0 means what? Mod A 0, O mod B 0, O cos theta 0. That's why we use, if A B not equal to 0, then cos theta only possible chance for 0, then theta equal 90 degrees. Like here, if A and B equal to 0, where A and B not equal to 0, then A 0, B 0, sin theta 0, n is 0. Here, if A multiple B is 0, A is 0, mod of A is 0, O mod B is 0, O sin theta is 0, O unit vector is 0. But you know unit vector means magnitude is 1, it never comes 0. We assume that A and B are not 0 question here, therefore sin theta only chance for 0. So what is sin theta 0? That means theta is 0, or theta is pi. Theta is 0, theta is pi. Therefore, in this case, the dot product A dot B 0 mean two vectors are right angle to each other. Remember these notes. And A cross B problem equal to 0 means sin theta 0. Therefore, here lines are parallel. A and B are parallel, right? That's the only fact here we have to take this question. They said OQ and the PR line, the product are 0. Therefore, these two lines are parallel. These two, if I mark somewhere here, these two lines are parallel. So only that fact, that application, we have to apply in the cross product method here, right? Therefore, these two lines are parallel. Now they are show that the OR vector is given, that pattern lambda. We have to find what is lambda. Lambda is a constant, okay? So what the idea? If two vectors are parallel, if they are equal, or one is long, so produce long side, long length, then the other, they are parallel. So here I take, let vector PR equal some alpha times vector OQ. Before that you write this, PR cross OQ equal to 0, therefore PR parallel to OQ, right? If PR cross, that means multiplication, OQ equal to 0 vector, then PR vector parallel to OQ. Copy that note and come to this. Therefore, I can take PRE sometime 5 times of the OQ, or 2 times of OQ, or half times of OQ, like this. So where alpha is a constant. Alpha is a constant. So vector PR equal alpha into OQ. What is OQ? 5i plus j. 5i plus j. Okay. Now therefore I mention alpha. They also shown as lambda. We'll see what happened my alpha and their lambda terms. Now come to this triangle. Use the vector addition. In triangle OPR, what is OR equal? OR equal OP plus PR. OP plus PR. So what is OP? 2I plus 3J. What is PR? I'll find 2, 5I plus J. I'll find 2, 5I plus J. It's a nice question, this work. Now simplify the I components separately, J separately. So 2 plus 5 alpha into I plus 3 plus alpha into J. They also said something OR. Compare this and see what happened. Yes, therefore alpha is lambda. Alpha is lambda, right? Therefore we compare that, therefore, but I mention alpha, that is their constant lambda. So therefore you can write that answer OR is this. So therefore here we use only one knowledge about the cross product or vector product. Vectors, there are two multiplication knowledge, two product of vectors. One is scalar product, that is we need the cos theta. Other one is vector product, that's we need sin theta. Okay. Now they say find the value of lambda if OR perpendicular to the OQ. OR and OQ 90 degrees. OR and OQ, that you know. That is our ordinary scalar product. If two vectors are perpendicular, better we use the dot product, scalar product. OR perpendicular to OQ. Therefore, OR into OQ is 0. Vector OR perpendicular to vector OQ. Therefore, OR vector dot OQ vector equal to 0. So apply what is OR, that is OR, right? 2 plus 5 lambda into I into OQ is 5I plus J equal to 0 or 0 vector. So multiple these two bracket. So you know I dot I is 1, I dot I is 1, therefore this into 5, you know, 2 plus 5 lambda into 5. I dot j is 0, right, equal to 0. So there is 2 plus 5 lambda 0, therefore lambda equal minus 2 over 5. It's more simple question like a structure type, but good idea about the knowledge of this cross product. So lambda equal is it OR into OQ. OQ is 5I plus J. Oh no, I miss that. I missed the J. See, I missed that. So OR 2 plus 5 lambda into I plus 3 plus lambda. So I hope you work clearly. I missed that. Into OQ, what is OQ? 5I plus J. So multiple I dot I1, therefore 5, 2 plus 5 lambda J dot J1, therefore 3 plus lambda equal to 0. I into I1, so 2 plus 5 lambda into 5 J dot J, so I can simplify, get the answer. So 10, 13 plus 25, 26. So lambda equal minus half. So I hope you complete successfully. I made a mistake that I'm not sure that 3 plus lambda J component. Simple question, but good idea about the cross product. Remember, not always we use dot product only. Sometimes rarely they can ask something, the knowledge of the application of the cross product. Okay, we'll see another question next, number 14. Right, problem 14, next question. ABC is an equilateral triangle. ABC is an equilateral triangle ABC is an equilateral triangle such as AB vector equal to lambda I, AB vector equal lambda I, show that the vector BC, show that the vector BC in terms of, or in the form of x vector I plus y vector j, x vector I plus y vector j, where x and y are constants to be determined. X and y are constant to be determined in terms of lambda. It's another small 25 marks, like a structure type. So stop the video, pause and try on. Equilateral triangle. The angles are 60 degrees and they are equal. AB is given lambda vector I. In the question, show the vector BC, that in the form of x plus iy form. Show the vector BC. How that? So you know that equilateral triangle, therefore AB vector, its magnitude, or AB equal BC equal AC. Three sides are equal. That means they are in vector notation. Modulus. BC modulus equal to AC modulus. Now you know the AB modulus, what the mod of a vector? Square root of the I component square plus j component square. Therefore that is this square root of lambda square, no j component here. So answer is lambda, right? Answer is lambda. So all the length of these sides are lambda. Okay. Now we find what is the AC vector they ask. It's a nice question, small part, but sometimes confused. You couldn't work this. You not properly learn some idea, some complexity there. Okay. So AC. We don't know what is vector BC. Only vector AB is given. We don't know what is vector BC. Therefore, you can't complete. If you know vector BC, then we can shape. We can work with some part of the AC vector in terms of something ij or any component. The idea is we find the BC, or if you know the AC, you know that question is find the BC vector. Find the BC vector. Now, if the AC known only, you can go ahead. Therefore, I use something like this. See, it's correct. I draw a perpendicular here. I say M. Okay, I say that is M. So therefore, M is half of the complete lambda size. Lambda size, therefore half lambda. M is half lambda. The length of AB is lambda, no? The half lambda, right? Therefore, I can complete. What is CM? CM vector. Now this is perpendicular vector. This is I component. Therefore, perpendicular, that is lambda, j component. You know to write a vector. If you know a vector, its magnitude, and a unit vector along that side, you can write any vector form. For example, see for example, OL vector. OL vector equal to OL magnitude into unit vector on that direction. Unit vector along that direction. So if you don't know, noted this, right? Any vector can be shown as its size, its magnitude into unit vector along that direction. Unit vector along that direction. That means I direction or J direction or sometimes K direction, or if they provide a new unit vector form. So OL vector equal example explaining here. It's example if it's XY. How to write the vector XY? Its magnitude and unit vector into unit vector along that direction. Unit vector along that direction. Okay. Yeah, my target here. What is MC vector? If you can find the MC vector, then take this triangle. You know AM vector. You know MC vector, you know the AC vector. If you know AC, take the big large triangle, complete the vector addition, that's all. If you take that small part, if you cover it, if you reject, that means break that point, it becomes simple part. Therefore, what is CM? What is CM equal? CM equal what? CM equal, this is lambda, lambda sine 60, lambda sine 60, CM equal lambda sine 60, lambda sine 60 root 3 by 2, sine 60 root 3 by 2. Therefore, can I write this MC or CM vector? I say MC vector. What is MC vector? Therefore, its magnitude along its unit vector. Therefore, lambda by 2 or root 3 lambda by 2 its magnitude and the unit vector that direction J. It's very important. So this is the MC vector, which is perpendicular to the AB vector. Therefore now, in triangle ABC, come to triangle ABC, use the vector addition. The question, find the AC first. Need ABC, take ACM, right? Take the vector triangle ACM. What is AC equal? AC equal to what? AC equal to what? AM plus MC. AM plus MC. AM plus MC. Okay. What is AM value? What the AM vector? AB size is lambda. So the midpoint, no, M is a midpoint in an equilateral triangle or an isosceles triangle. If you draw a perpendicular, it bisect it. Therefore, AM value lambda by 2. Lambda by 2. Along that direction, unit vector is I. Plus MC is root 3 by 2 lambda into J. This is the AC vector. Then go to the answer. Take the big triangle ABC. Take the big large triangle. In triangle ABC, what is AC? Question is find the BC. So take subject BC, subject BC. BC vector. BC vector equal to what? BA plus AC. BA plus AC, right? Therefore, what is BA? AB lambda I, so BA minus lambda I. AC, we found the AC here. Lambda by 2 I say half lambda plus root 3 by 2 lambda j. So complete this is in the form of ij separately. What is minus half I lambda root 3 by 2 lambda j. And therefore they are show this vector in the form of x vector I plus y vector j. Nice part. Therefore x equal minus half lambda, x equal minus half lambda, y equal root 3 by 2 lambda, y equal root 3 by 2 lambda, right? Nice question. Using this equilateral triangle, all the sides are equal, use 60 degrees also. This question 14 problem and the 5th video. So I hope you understand this. So better you go my previous all in a video in order, then you'll get some good knowledge of how to use, how to apply the product of vectors, geometrical issues, ratio problems. So good revision type question this.